So what these are for is to take and cap off code 61 and code 62 lines. You see how thick that one is? That's a code 62. You see how skinny this one is? That's a code 61. But that's what these are for. So if you take something apart, you know, it's not like you can just screw a cap on the end of your line. Sometimes you can use these plugs, like if it's coming out of a valve bank, you use one of these. You use the same old split face couplings and put the plug in there to keep the dirt out of the valve bank. But if you got a hose laying out there wild, then you got to use these. But they are expensive. But at the end of the day, I've had time goes by when you're having fun. Anyhow, if you're going to cap off a line, that's what you use them for. So here's a 32, just to show you how big a 32 is. Pretty good size, isn't it? I'm going to try to find a... That's kind of nice how, see, they at least show you that's a 61 series and a 62 series. Number 12 61 series, number 12 62 series. Here's a 24 here. 24 61 and a 24 62 series. So you get my gist as to when you take something apart, you know, clean it up, put a cap, put a plug, blank it off with a blank like this on a valve body or something. You can buy these things. They're not that expensive. And keep the dirt out. You can buy JIC plugs and caps. If you had a half-inch pipe thread, you can go to a hardware store and buy some plugs, and, you know, I mean, just keep the dirt out. You don't want to be like the air conditioner hose and have the mud daubers fill you up. Gotta love them mud daubers. Sectional control valves. This particular valve has number 8 O-ring boss or SAE fittings in the ports, and the supply and return are number 10 SAE O-ring boss ports. When selecting a valve, you always want to pay attention when you're buying a sectional valve. You're going to buy an inlet plate, you're going to buy an outlet plate, and then you're going to buy whatever type sections that you want to put in there. You can buy some sections that are detinted, so that when it gets to 1000 psi it kicks back to neutral. You can get them where you have to manually hold them in both directions no matter what's going on. You can get them electric with a 12-volt solenoid on one side to activate it one way and a 12-volt solenoid on the other side to activate it the other way. You can get the end plates with front or top or multiple places you can put your inlet. The outlet can have a pressure regulator in it if you elect to put one with a pressure regulator in it. There's just so many different things that you can put together when you're putting together a sectional valve. So if you wanted 7 spools or 4 spools or 2 spools, whatever you want to put together, you buy the parts accordingly, and then you buy the bolt kit and the O-ring kit that goes between each section, so as they sandwich together, that these tie bolts are the right size and the O-rings are to fit. And you put it all together and you put it on your machine and you go to work. There's 2 basic types of sectional control valves. You have an open center and a closed center. So the open center lets fluid run from the inlet to the outlet, and just it's a complete circuit, you know, it'll circulate. A closed center, it won't do that. A closed center will only let oil go through when you pull on one function, and they run load sense and they run a swash plate style of a pump. You're probably not going to be running a swash plate pump. My big log splitter runs a swash plate pump, a swash plate piston pump with load sense. They're expensive, they cost a lot of money, and for what I'm doing with it, for that it's perfect. But for what you're probably going to use, you're probably not going to. You're probably going to run an open center with a regular pump and go on about your business. But just to touch base with you about sectional control valves, and you look in these magazines and you want to pay attention to the gallon per minute flow. So everything is gallons per minute. So if you're going to run 8 gallons a minute, you're going to run 15 gallons a minute, you're going to run 20 gallons a minute, this valve is going to get bigger or smaller depending on how many gallons a minute that you run through it. So you really got to pay attention to that. Other than that, that's about it on sectional control valves. There's a piece I'm going to put at the end of this video on the SPA stub. A lot of people don't know what an SPA stub is, but basically it's like a PTO end with a whatever size shaft that you're running on your motor, and also the keyway size. One thing I forgot in the last one too to tell you was when you buy your motors, you can buy them with a 2-bolt or a 4-bolt flange. It's just personal preference on how you want to mount it, whether you want to go, this is a 4-bolt, so the bolts actually thread into it. The 2-bolt has ears that stick out where you can bolt it up to something. So a 2-bolt and a 4-bolt, I forgot to tell you that the last time, so just be aware of that. It makes life a lot easier if, depending on what type of application that you're going to use that in. Let me get these off to the side. And the next thing we want to talk about is we want to talk about hydraulic cylinders. So this cylinder right here is called a tie bolt. I'll get my tongue untwisted here in a minute. Tie rod cylinder. So you can see it's got 4 tie bolts that hold it together. It's got a head plate, a tail plate, and a round tube in the middle. They're usually around 2,500 psi is usually about the working pressure of a cylinder like this. This particular cylinder has 1/2-inch national pipe thread inlet and outlet. They use this is what they call a clevis end, a 1-inch pin clevis end, and the same on the other end. It's a 1-inch pin clevis end, and it also has, you can change the port setting from top to side the same way with this one here. Oh, this one doesn't have it. So if you want to change it to the side, you just unbolt the head, rotate it 90 degrees, and bolt it back on again. The length of the cylinder is always from pinhole to pinhole when it's collapsed. And then the stroke of the cylinder is when it's expanded. So if you subtract those two, that'll give you the stroke, and when it's collapsed, that gives you the length of the cylinder. Pay attention to your fittings, whether it's O-ring boss or if it's pipe thread, as to whatever you're wanting to use on your whatever you're making. These clevis ends, you can see this one here, it threads on, and it's got an anchor bolt that cinches it around that thread so you can get some fine adjustment out of it. Pretty nice sometimes when you're trying to get something so that it goes down and it hits a certain stopping point. So that works pretty good. The other style of a cylinder is called a welded barrel cylinder. So you'll have a big tail stock, and then the tube itself will be welded solid to the tail. The head gland on the front will be removable, where you can get in there and change packing, cylinder rod seals, and whatever. But they usually run up, you know, they can be 2,500 and up. They usually are really a good cylinder. And you can get them with a tube end on them. You can get them with an eye end on them. It just depends on what type cylinder and what application you're going to use it in. The thing that is interesting to know is that the way you figure a cylinder and how big of a cylinder that you want to use. So this particular cylinder here is a 3-inch bore cylinder, which is how big the piston is inside of here on the tail end is 3 inches in diameter. So if you had a 3-inch diameter circle, that was your piston, you'd have to figure out how many square inches of area is in that 3-inch circle. So I did the math on all this already and I got it all figured out for you. A 3-inch piston has 7.06 square inches of area. So that's how much area that pressure is pushing on to make that cylinder extend. If you were to put 3,000 pounds on a 3-inch cylinder with 7.06 inches of area, it would have 21,180 pounds of lift. So when you're trying to figure out how much work that you're wanting to do with it, then you have to figure out, what am I trying to pick up? The other thing is some cylinders are two-way cylinders, so they're power up and they're power down. Some cylinders are one-way. Oil pushes them up, gravity pulls them back. That's a one-way cylinder. One-way cylinders are usually cheaper. You can use one-way cylinders and put a vent in the top of a two-way cylinder if you want to use it that way. But like a dump trailer, if you see a dump trailer where you got an electric power pack and the power pack picks the cylinders up, then the weight of the trailer brings the cylinders back down. So they're just one-way cylinders. So you know what you're looking at when you look at something like that. One thing you want to be aware of is the fact that if you're finding used stuff laying around, they make a pneumatic cylinder that runs on air. And usually they run up 300 psi air. Well, a 300 psi air cylinder, and you all of a sudden decide you're going to put 2,500 pounds of oil to it, that dog don't hunt. So you want to be very careful about, if you're finding used stuff laying around someplace, exactly what you have. And always remember, if it's used and it's been laying around for a long time, that the piston packing and the cylinder head packing and all that's probably going to be dried up in it. So you're going to have to take it apart right away and see if it's even any good to use before you waste all the time of making something, and then you find out that your stuff's no good when you'd have been better off you just went and bought a brand new cylinder to begin with. So 2 cents worth on that. What I did was I had an 1 1/8 shaft with a 1/4 inch keyway, and you can buy these. They call them an SPA stub, which looks like a little miniature PTO stub, and that slides right on your motor, and there's an Allen screw that holds it down. Then you can use your regular drive line that used to be your PTO drive line and put it right on that SPA stub. This one's belt driven. It ran nice and slow on I had a 753 Bobcat. It ran nice and slow on my 753 Bobcat, but when I put it on my Kubota, it's pumping closer to 20 gallon a minute, and it's running it too fast. So if I was going to keep this thing, I would want to put a flow control on it and slow that oil down, because it's just pumping too much oil for what I'm trying to do with it, thank you for watching. All right, we'll see you.